The explosion itself lasted only a few seconds, but what followed stretched across an entire week. And what scientists captured during that week may be the most important geological data set ever recorded at Yellowstone in the park's entire history of modern monitoring. On the morning of June 13th, 2026, in the pre-dawn darkness, just 9 minutes past 5 in the morning, Mountain Daylight Time, monitoring equipment inside Biscuit Basin in Yellowstone National Park registered something that did not fit the normal thermal background signature of the basin. This was not the slow, familiar heat creep of a warming thermal spring. This was a sharp burst of seismic energy paired with infrasound, a low-frequency pressure pulse sitting below the range of human hearing entirely, originating from the direction of Black Diamond Pool, a hydrothermal spring located approximately 2 miles northwest of Old Faithful. If you follow Yellowstone at all, that name already carries weight. Black Diamond Pool became infamous on July 23, 2024, when it produced one of the most dramatic hydrothermal explosions ever caught on camera in the park's recorded history, hurling water, mud, and fractured rock between 400 and 600 feet into the air and destroying the boardwalk where tourists had been standing moments before the blast. Biscuit Basin has been closed to visitors since that day, so when the instruments lit up before dawn on June 13th of this year, the immediate assumption among monitoring staff was straightforward. Black Diamond Pool had blown again. The data stopped fitting that story almost immediately. The temperature sensors sitting inside the pool itself barely moved. If the pool had detonated again with the force the seismic and acoustic signal suggested, those sensors should have spiked violently and unmistakably. Instead, they registered only a small, modest change. Something had clearly exploded. The signals left no doubt about that, but it had not exploded from the famous pool everyone had been watching. The answer came from a camera that had only been installed at the site the previous year, in May of 2025. At 9 minutes and 50 seconds past 5 in the morning, the camera recorded a dark plume of steam jetting upward. Not from Black Diamond Pool, from barren, entirely unremarkable ground just to its north. The earth had torn open in a spot with no famous feature, no named spring, no historical significance, just flat thermal ground that had never done anything notable in recorded memory. That single detail is the thread running through this entire story. For nearly 2 years, all the scientific and public attention at this location had been fixed on one specific pool. And on June 13th, the ground opened up right beside it, in a place nobody had been watching closely at all. When geologists reached the site, they found not one new opening, but three. 3 separate sets of freshly formed vents punched into the ground north of Black Diamond Pool, none of which had existed the previous day. Large volumes of near-boiling hydrothermal water had surged through these vents and flowed downhill into the Firehole River. By the time scientists arrived, most of the vents had already stopped flowing, but the northernmost one remained active, still feeding water steadily into the river. That northern vent came with a detail that communicates the forces involved more clearly than any measurement. It was connected to a crack running through the ground, oriented roughly north-northwest, stretching approximately 18.5 meters, about 61 feet in length. In places, this fracture gaped open as wide as 1.5 meters, nearly 5 feet across. A fissure longer than a school bus, and wide enough in spots to swallow a person whole, opened in a single morning in ground that had been completely solid the day before. The water pouring from these vents measured around 90 degrees Celsius, essentially at boiling point given Yellowstone's high elevation. This was not warm water seeping gently through permeable rock. This was near boiling water being violently forced upward under intense pressure. Downstream, the Firehole River changed color visibly enough to be seen from miles away. It turned a pale milky gray, the unmistakable signature of water carrying a heavy load of fine sediment. That discoloration drifted approximately 6 kilometers downstream toward the Midway Geyser Basin. The gray water is a physical receipt for what happened underground. It is direct visible proof that the shallow plumbing system beneath Biscuit Basin flushed a large volume of sediment-choked water out of itself in a very short window of time. The ground had emptied part of its insides directly into the river, but the ground was not finished. This is the part of the story that has no real precedent in Yellowstone's monitoring history, and it has nothing to do with how large the original explosion was. In the days following June 13th, scientists watching the site observed something new forming that simply had not been there when they first arrived. A brand new pool of water appeared near the middle group of vents, vigorously boiling, gray, thick with suspended sediment. The way this pool formed is what matters most. Most new thermal features that suddenly appear at Yellowstone are explosion craters, holes punched outward by a blast, surrounded by an apron of ejected rock and debris that marks the perimeter of the event. This new pool had no apron of blasted-out material around it at all. According to the United States Geological Survey, this pool did not form through an explosion. It formed through collapse. The ground caved inward, sinking down into the hot, pressurized zone beneath it, and the resulting depression filled progressively with boiling water. The original blast happened on June 13th. This new pool formed sometime between the afternoon of June 14th and the morning of June 16th. The explosion was not the end of the event. It was the opening act of a longer, quieter process that kept reorganizing the subsurface for days afterward. The measurements make this tangible. The new pool measured approximately 6.5 meters by 5.5 meters, roughly 21 feet by 18 feet, filled with boiling water where solid ground had been standing days earlier. And it did not sit there quietly once it formed. By June 18th, the pool had begun erupting on its own, working through several sustained episodes of spouting, throwing water 6 to 9 meters into the air, between 20 and 30 feet, roughly the height of a 2- or 3-story building, in repeated multi-minute bursts. Think about what collapse means here rather than explosion. An explosion is a single violent release that ends within seconds. A collapse is slower and reveals something more disturbing. It means the ground beneath the surface had been sufficiently hollowed out or weakened that it could no longer support its own weight. It sank days after the initial blast without any surface indication that anything was wrong above it. A person could have walked directly across that ground in the interval between the June 13th explosion and the June 14th to 16th collapse. It looked intact. And then, on its own schedule, without any external trigger, it quietly gave way into near boiling water underneath. The full sequence is the true anomaly here. An explosion on day 1 producing a fracture in 3 vents. Then 2 to 3 days later, the ground collapses inward, forming a brand new boiling pool where solid ground had been. Then 5 days after that, the new pool begins spouting entirely on its own initiative. The hazard did not end when the initial blast stopped. The system kept failing, kept shifting, kept opening new expressions of instability for the better part of an entire week. And this brings us to the number that makes all of it scientifically extraordinary. 100 meters, approximately 328 feet. That is the distance between where the June 13th explosion occurred and a monitoring station the Yellowstone Volcano Observatory installed the previous summer in 2025. According to the USGS, no hydrothermal explosion in Yellowstone's recorded history has ever occurred this close to dedicated scientific instruments positioned to capture it in real time. Not once. This is the closest proximity any instrument suite has ever had to an event like this as it actually unfolded. To understand why that distance matters so much, consider the contrast with the 2024 explosion. When Black Diamond Pool detonated in July of that year, there was no hydrothermal monitoring station anywhere near Biscuit Basin. The observatory's broader instrument network barely registered the event at the resolution needed for meaningful analysis. One of the most dramatic hydrothermal blasts in the park's modern history happened, and the instruments largely missed it. Scientists were left studying the aftermath, working backward from scattered debris with almost no real-time record of the event itself. Distance degrades everything in seismological and acoustic monitoring. A seismometer sitting miles away records a smeared, attenuated signal. A seismometer 100 meters away captures the sharp, high-frequency fingerprint of rock fracturing in real time with detail that distant instruments cannot provide. An infrasound sensor positioned at that range captures the exact acoustic signature of steam breaking through the surface crust, not a muffled echo, arriving seconds after the fact, but the actual pressure wave as it generated. A camera at that distance does not simply confirm that something happened. It timestamps the plume to the half second and identifies the precise patch of ground that gave way. Multiply that across 4 different instrument types, all running simultaneously, all within approximately a football field's distance of the blast, and the result is something this field of science has never had access to before. A clean, close-range, multi-sensor recording of a hydrothermal explosion from inside its own immediate neighborhood. Every instrument running, every sensor capturing, every second of the sequence recorded. What those instruments did or did not detect in the moments immediately preceding the blast is now the most important question in Yellowstone hydrothermal hazard research. And to understand why, you need to understand what is happening below the surface when these events build toward failure. Underneath Yellowstone's thermal basins, hot water circulates constantly through a network of shallow cracks and channels running through the rock. That water carries dissolved silica picked up from the surrounding rock at depth. As it rises toward the surface and cools, the silica precipitates out of solution and deposits onto the walls of these underground channels, building up a hard, glassy mineral coating that thickens over time. And here is the trap embedded in that process. Silica coating is essentially impermeable. As it thickens, it can seal a conduit that had previously been venting heat and pressure safely upward. Once sealed, the hot water and steam trapped below have nowhere to go. Pressure builds, temperature climbs. The result is superheated water held under intense pressure beneath a mineral and rock seal, essentially a natural pressure cooker buried just feet beneath ground that millions of people walk across every summer. The ground above it looks completely ordinary. There is no surface expression of what is building underneath. It stays that way, looking unremarkable and stable, until the confining seal can no longer hold. When it fails, pressure drops instantly. The superheated water flashes explosively into steam. The steam expands with enormous force, and the ground above either blows outward or, as the days following June 13th demonstrated, destabilizes and collapses inward while continuing to reorganize itself for a week. Now bring those instruments back into this picture. The single most valuable thing those sensors at 100 meters could have captured is a precursor, some signal in the minutes or hours before the explosion indicating that the underground seal was approaching failure. A gradual temperature change in nearby sensors, a subtle shift in infrasound readings, a sequence of micro-earthquakes too small to feel but detectable at close range as the rock began fracturing. If that kind of signal appears in the data from June 13th, the observatory may have its first real foothold on the problem of forecasting these events. A potential basis for saying, even minutes in advance, that a specific section of ground is approaching failure and should be evacuated. But there's a darker possibility, and Yellowstone scientists are being direct about it. The 2024 explosion gave no clear warning. If the close-range data from June 13th also shows the ground was completely quiet right up to the moment of failure, then the most troubling version of this hazard is confirmed. These events can strike out of apparent calm with no detectable precursor whatsoever in terrain where millions of people walk every summer. Either answer is significant. This is genuinely the first time the data needed to answer the question has ever existed. The broader context of what has been happening at Biscuit Basin makes the June 13th event even more significant. This was not an isolated incident arriving without precursor at the location scale. It is the latest development in an ongoing period of instability that has been running for nearly 2 years. The July 2024 explosion was followed by smaller eruptions at Black Diamond Pool in May of 2025 and December of 2025. Most of those intermediate events went unwitnessed because the area had been closed to the public since the original 2024 blast. But instruments and trained observers documented them. The basin has been closed continuously for nearly 2 years now. That closure reflects the National Park Service's ongoing assessment that the ground there is not safe to stand on and has not become meaningfully safer with the passage of time. The pattern across those 2 years is not that of a system that experienced one dramatic event and then gradually settled back toward equilibrium. It is a shallow underground plumbing network that has been actively reorganizing itself, finding new weak points, opening new pathways, and persistently refusing to return to the stable configuration it maintained before July 2024. The 2024 explosion reads, in retrospect, less like a one-off accident and more like the opening of an unstable period that is still ongoing. June 13th, 2026 is what that ongoing instability looks like when it finds a new section of ground to express itself through. Now, let us address the reaction this has generated in certain corners of the internet, because it requires direct engagement. Every time Yellowstone does something that produces dramatic imagery, the same wave of claims floods social media within hours. The supervolcano is waking up. The government is hiding an imminent catastrophic eruption. The new vents and the boiling pool and the steam are the final warning signs. The data contradicts this entirely and clearly. Yellowstone's volcano alert level remains at normal. The aviation color code remains green. Through the month of May, the park recorded only 45 small earthquakes in total, the largest of which measured magnitude 2.0, a tremor, imperceptible to anyone standing directly on top of it. There were no earthquake swarms. There was no ground deformation anywhere in the system. There was no signal within the broader magmatic infrastructure suggesting magma is moving toward the surface. A hydrothermal. Explosion at the scale of June 13th is a shallow local steam event driven by groundwater pressure at depths of just a few feet. It is not driven by magma. It is not a precursor to caldera-scale activity. On the supervolcano question, the science is clear and the situation is calm. But here is what the online reaction consistently gets backwards, and it matters. There is a real hazard at Yellowstone. It is not the one appearing in disaster movies. The genuine danger is not lava. It is not a caldera eruption. It is exactly what has been described throughout this story. A thin, sealed crust of ground holding back near-boiling water in places where tourists walk every summer, which can give way with little or no warning at all. In 2024, it destroyed a boardwalk full of people who narrowly escaped before the blast. The fear circulating online is real fear. It is simply aimed at the wrong target. People are alarmed about a magma chamber miles underground, while the thing that has repeatedly demonstrated the ability to actually hurt someone is a few feet beneath their own feet. To hold this in appropriate proportion, small hydrothermal explosions at the scale of June 13th happen somewhere in Yellowstone roughly once per year. Larger events become progressively rarer as they increase in scale. A porkchop geyser-style explosion, similar to the 1989 event, that left a debris apron about 15 feet across that remains visible today, occurs roughly every several years. An event large enough to leave a significant crater behind happens on the order of once every several centuries. The largest hydrothermal explosion crater on Earth sits along the north edge of Yellowstone Lake, a feature called Mary Bay, approximately a mile and a half across, blasted out roughly 13,800 years ago. Measured purely by physical scale, the June 13th event sits comfortably at the small and relatively common end of a very long historical range. What is genuinely unprecedented about it has nothing to do with its size. It is the combination of two specific factors. First, it is the closest any hydrothermal explosion has ever occurred to. Dedicated scientific instruments running at the moment of the event. Second, it is the first time scientists have documented on camera a new pool forming through collapse in the days following an explosion and then beginning to spout on its own. That sequential failure, stretched across a week, captured in detail by instruments 100 meters away, is the genuine first in the geological record here, not the explosion itself, the unprecedented proximity of the instruments, and the documented slow-motion failure that followed. What to watch going forward is specific. The Yellowstone Volcano Observatory now holds a dataset, unlike anything previously available to it, and the analysis of whether any precursor signal proceeded. The June 13th blast is the central question everything else hinges on. If a precursor is confirmed in the data, it represents a meaningful step toward the ability to forecast these events, even in short windows of time. If the data shows no precursor at all, the honest scientific conclusion is that this particular category of event can occur without any detectable. Warning, which means Biscuit Basin will remain closed, and the implications for how visitor safety is managed across other thermal basins in the park will need to be reconsidered in that light. The new collapse pool that formed between June 14th and June 16th deserves continued monitoring as well. Whether it stabilizes, continues spouting, or develops further will indicate whether the underground plumbing system is still actively reorganizing or beginning to settle into a new configuration. The supervolcano is not waking up. The data on that question could not be more reassuring, but the ground inside Yellowstone's thermal basins has demonstrated in unprecedented detail over the past week that it can tear open, collapse inward, and boil over for days without resolution. And that the most realistic hazard in America's oldest national park is not buried, miles underground waiting for a geologic trigger. It is hiding quietly beneath the surface that the next group of visitors will be walking across when the park eventually reopens that section. 100 meters away, every instrument running, everything recorded. And the most important question in Yellowstone hydrothermal hazard science is now whether what those instruments captured in the seconds before June 13th was silence or something else entirely.